Hello, everyone. I'm Hao Xin from the Baidu Security Department. I'm very glad to have this opportunity to participate in the HITB security meeting. And it is also a great honor to share and exchange our research content here. Today, my topic is transferability of adversarial examples to attack cloud-based image classification service. This topic is a little different from the papers we contributed. This paper used the point image detection as the experimental object. When we found that no matter it was point image detection, violence detection, or object classification, it was an image classification problem. During our experiments, we found that our method is very general. So in today's speech, the classification services are taken as the research content to share with you. Briefly introduce our team's field of work. The direction of my work is AI model security, including research on the model attack and defense methods, and also provides solutions to security risks of various AI applications, such as fake face detection, model robustness evaluation. They are included in the AI Security Toolkit ADV books. We also have heavyweight security objects such as Mesalink, Mesalog, and OpenRasp. And most of them are open source, placed on GitHub. The following is the main topic of today's discussion. At present, when AI brings us convenience and surprise because of the existence of adversarial examples, the safety of AI has to be mentioned and discussed. This shows that the more widely AI developers, the more attention products and customers will pay to safety needs. Various image analysis methods emerge from the earliest image classification to object direction, 3D detection, semantic segmentation, fake face. But for most of them, image classification is a basis. Most major internet companies provide image classification services, and most of them can be displayed through the cloud API. For example, you can upload an image to ask Google, what is it? You can get a real answer from the cloud, a cat. At the same time, attacker can make the cloud think that it is a dog. It simply adds some carefully constructed partitions to the original image, which is the adversarial example. It can fool AI classifier, but it is not easy in the real world, and it is more difficult to influence multiple cloud classification services at the same time. What we are showing today is that by using our attack method, the same adversarial image is misclassified on the multiple cloud services. The security of the AI model comes from the transparency of its important information. If the model network structure, parameters, and the input of the AI model are open, then it lacks an open door for an attacker. They can easily generate adversarial examples against the model. This is a white box. After the original image is modified, the cost of the image distortion is very small, and it is almost impossible to find the attack trace. So, unless is teaching and research, commercial use must avoid using white box, even if only using the white box model for transferable training is very dangerous. The other is the black box model. The attacker can't get the important information about the structure and the parameters of the model directly, but he can repeatedly try to verify the effect of the attack and guess the important information of the model. That is also very difficult because it's not the same as brute force cracking, and there is a lot of computing time cost. The AI service provided by the cloud is also a kind of black box model, but it has less information and more limitations than ordinary black box model. Not only the structure and parameters are unknown, but also the input processing of the model is unknown, such as clipping, filtering, and affine transformation. There are many bottlenecks for using repeated attack to get more information of model, because the entrance of the model can increase the access frequency limit, which makes the cost and the difficulty of attack increase greatly. Understanding the difficulty of attack, let's look at the common cloud-based black box attack method. First, based on the attack of the query, the black box is repeatedly required thousands of times, although the gradient of the model cannot be obtained directly. Some important information about the black box model can also be obtained. Only for low-resolution images need more than 1,000 requests. The cost of the high resolution is several times. Papers published in 2017 used this method to complete black box attacks using nearly 10,000 requests. It makes this attack expensive and slow. Second, using transferable attacks. The DNN of the adversarial examples with a similar structure is transferable, which was confirmed in Dangsong's paper in 2016. The comparison chart in this paper is cited here. It shows that the adversarial effect can be transferred to some extent by using similar methods to train the same function model. But the challenge is how to find open source models with the same function, because cloud-based AI services are black box and cannot get information about the model structure. Attacks on cloud-based AI services have certain conditions. Some of them are very harsh and difficult to achieve. Does it mean that the way of the cloud services is safe enough? Here is an example of using our method against cloud classification services. This is a British long-haired cat. Google's image classification gives the right answer. This is an adversarial example generated by our method. Although it is impossible to get the model information from Google, the attack is still successful. Although there are some perturbations and distortion, the difference between the adversarial example and the original image is not very large. How did we do it? We use a loss function to compute feature similarity and define it as FFL, which can increase the transferability of attacks. We rebuild the dataset of the model, which is small, and request the cloud-based services only 1 or 2 attempts per image. We use AutoDL to generate white box model instead of the cloud-based services. Generally, our attack steps are divided into 2 steps. First, we use the query of Cloud API to construct a small amount of dataset and use it to training the substitution model. Second, the substitution model is used to generate adversarial examples with better transferability. I will introduce the process of these steps in detail. We want to train an image classification model, and we choose ImageNet as the pre-training model. The contrast diagrams with the different constructor currency shown here. Its value also means the ability of the feature extraction. It is more suitable to choose the structure with higher feature extraction ability as a substitution model. If you choose a structure that is closer to the model behind the cloud-based services, it will certainly be easier to succeed. The substitution model is only retrained for the categories that need to be attacked. And its feature in this category is expected to be more similar to the target model. So when we use untargeted attacks, if you only attack cats, then we only need a binary classification, cats or not. We fix the parameters of the feature layers and train only the full connection of the last layer. The training process can be described as follows. We determine the characters of attacks, select attack images, and integrate these images into our training site, which can have dozens of fewer. These images are predicted through the cloud services, and the results are labeled so that the small dataset is successfully constructed. To reach the output of the binary classification, we also need other animals' images in this training site. Training substitution models takes time, of course, but the cost is limited to attackers, and the cloud-based services can't intervene. Because the dataset is very small, and there are only 2 target characters, too many parameters will take the training overfitting, and the features are not easy to be robust. So that we want to make the features of the substitution model more robust. It is a way to reduce the center number of characters. Besides pruning, there is another way to reduce parameters, that is auto-DL transfer. We can generate a more reasonable model through auto-DL after the substitution model. The structure of the new model is more in line with the needs of this small dataset. Get smaller and more robust. The adversarial examples crafting. We propose a loss function called FFL for PGD attacks. It is used to improve the success rate of transferable attacks between different models. The traditional PGD attacks only use classification loss, resulting in model classification errors. We increase the loss of multi-layer feature maps to ensure that these features are more different from the original model. In addition to the classification loss, we will choose the output of the multiple convolution layers, the feature maps of different convolution to represent the semantic content of different dimensions. We choose several different convolution layer features to influence the feature weights at different levels. In different convolution layers, the first main recognizes edges and lengths. In the last convolution layer, it recognizes high-dimensional features such as eyes and nose. Here is a definition of the feature loss function. We take the Euclidean distance about a multi-layer feature map between the original image and the adversarial example as feature loss. Design and processing. The category to attack is the cat. We selected 100 images of cats and 100 images of other animals from the ImageNet datasets, and clip the image to fix the proportion and format. We don't have a validation set here. The image for attack are also selected from this training set. Predict and labeled the 100 original images through the cloud-based services, and then train the substitution model. We will use these 100 images to generate adversarial examples and make a black box and target attack against the real-world cloud-based images classification services. In our experiment, the ResNet 152 with higher accuracy rate was chosen as the structure of the substitution model. Using traditional PGD and FFL PGD methods, generate adversarial examples. Compare them to find which one has the better transferability. In addition to comparing the transferability, we should also pay attention to the gap between them. We need to measure the degree of distortion of adversarial examples. If the images are quite different from the original one, it will lose the meaning of the attack. So we use the PSNR to measure the quality of the image and the SSIM to measure the similarity between the original image and adversarial examples. First, look at the escape rates of them. We choose Amazon, Google, Microsoft, and Classifier as the target of attack. The average success rate of FFL PGD in these 4 different classification services is more than 90%. The classification service of each platform has a higher success rate with the FFL PGD method. It can be shown that FFL PGD has a better transferability. As for PSNR, with a general evaluation, higher than 20 is the image quality that human eyes can normally distinguish. Both methods are acceptable for image quality. The overall PGD is a little better than FFL-PGD, but it is also a very small gap. Look at their similarities. From the date, it can be seen that with the increase of step size, the similarity between the FFL-PGD and adversarial examples and the original image seems to be higher. And the gap between them is also very large. It means that every image modified by FFL-PGD does not change very much, which makes his SSIM still much better than the traditional PGD. The purpose of our comparison is showing that first, as the powerful attack method, PGD can also have a greater success rate for cloud API through our substitution model. And then the success rate of FFL-PGD have been greatly improved. Second, the measurement of SSIM and PSNR the same and or better than PGD. Finally, we do a set of comparison to verify the transferability of using Ensemble-model attack methods. This method assembles many different models to generate adversarial examples. We use it to compare our method. The model here chooses the mainstream, VGG, ResNet inception, using the ImageNet pre-training model. We can see that the basic success rate of these cloud classification services is less than 50%, which is much worse than our method. It is still very difficult to afford the traditional transferability method to attack the cloud classification services successfully. In conclusion, although the cloud model has strong black box capability, it does not provide absolute security. With our method, we can still successfully fool the different cloud image classification services and just use one or two queries on cloud services can complete the attack. The success rate of the attack and the quality of adversarial examples will guaranteed. At the same time, we can achieve the same results in other image classification tasks. So, this is the end of my speech. We hope to have more communication with friends who are interested in AI security. Thank you very much.